right, number 10 on 5.2. We'll finish up that lesson, then cover the next one, 5.3. Okay, so do I have all the information up here? I do. All right, find the value of x and y. Here we have x and y in this expression. Here we just have x. So if I'm finding x and y, I don't want to start out with the one with x and y in it because I would have to have two equations and two unknowns. We'll start here with this one, 2x minus 50. If I can set that equal to something, then I can solve it for x. But I have to figure out what it's equal to. It is not equal to 24. If you'll look at, this is important, this congruent statement, to help you figure out which angles are congruent to each other, because it's not always really obvious. It says that u is congruent to n, right? Because they correspond, the order that they're in. So we have to look at n. Well, we don't have an angle measure for n, but we can find it. When we have two angles of a triangle, how do we find the third angle?
You add those two together and then subtract that from 90.
Subtract that from 90, correct. So the measure of angle n plus 142 plus 24, all three angles add up to 180. That's the triangle sum theorem. Now, you can just add them up and subtract them from 180. You don't have to set up an equation. I just always like to whenever I can. That way we get really used to working with equations or making our own equations. So the measure of angle n plus 166 is equal to 180. Subtract 166 from both sides. And then that would be, what, 14? So the measure of this angle is 14 degrees. So I can say that 2x minus 50 is equal to 14. So add 50 to both sides. Divide both sides by 2. So we have x. Now we have to find y. So the only expression with y in it also has x. But instead of putting x there, I can plug in my x value. My x value is 32. And I have to figure out, see this m right here? That's the length. That helps you to know that's the length of the side of the triangle. Sometimes you have to use logic or elimination to figure out what it goes with. So the m here would be meters. And we have to look and see, well, it's more obvious that NP is congruent to SU, but we want to make sure. Is NP and US, that would be the same as SU. These two are congruent. Remember doing that on Friday where we had to match up the parts? So it is equal to 13. So that's 64 minus y is equal to 13. Subtract 64 from both sides. What is that, 51? If negative y equals negative 51, then positive y equals 51. Or you can just show where you divide through or multiply through by negative 1. Any questions? Okay, one more.
On
Yes.
the quiz or whatever, are you going to want us to like plug it in over there, or can we just subtract it from 180?
On this one?
Yeah.
You don't have to show that. You can just be, as long as you get it right, just be careful. Just make sure you get that right answer. But you do have to show this.
Plug it in, yeah.
Mm-hmm. Number 12, show that the polygons are congruent. Explain your reasoning. So it says to show that they're congruent. We don't have to determine if they're congruent. We have to show that they are. But we remember to show that two polygons are congruent. All corresponding sides and all corresponding angles have to be congruent. Well, we see already that these two sides are congruent to each other. These two sides are congruent to each other. What about the third side? Do we know that this side to this triangle is congruent to this side of this triangle? Do we know that? Yes. And I'll put 3 marks here showing that it's congruent to itself, which is, let's say that WY is congruent to WY by the, what property? Do you remember? Reflexive. Those are the two that I have to stop and think and make sure I don't get them backwards. It is the reflexive property. Okay, so now now the book in the back will show you show how they make the statements of the ones that are already marked here. I don't care if you do that or not. If it's already shown that they're congruent, you don't have to make the statement that they're congruent. But I do want you to make the statement that doesn't show anything. So like we don't have to show that these two angles are congruent to each other. We see that they are. So we don't have to make that statement. But we have 2 other pairs of angles that we have to show are congruent to each other. And there's something on there. Almost always. They usually, almost anytime they have something marked on the figure and you're trying to prove it, there's a reason that it's there. So you should be asking yourself, why are they telling us that these are parallel? There's got to be a reason, and there is a reason. If these 2 lines are parallel to each other, what angles are congruent? If this line is parallel to this line, and we have a transversal going through those 2 parallel lines, look, I can extend the sides, and that will look more familiar. What 2 angles, if any, are congruent? Which one? The one on the left or the one on the right? Left. Those 2 are congruent to each other. We don't know about the other 2 yet. These 2 lines being parallel do not affect these 2 angles because they're made with the other lines. So these 2 angles are not affected by these lines being parallel. These 2 angles are affected. So we'll say that angle XWY is congruent to angle ZYW. Because alternate interior angles of parallel lines, we can use symbols, are congruent. We have one more pair left. We have to show that these 2 are congruent to each other. See if I can move this out of the way. We have these 2 lines that are parallel, and they're cut by this transversal. Does that make those 2 angles congruent to each other? It does. So now we can say that angle XYW is congruent to angle ZWY. To me, the hardest part is naming the angles, because all those letters kind of... Anyway, all right, 2 different ways to prove that those 2 angles are congruent to each other. One way is the same thing I just used here, because alternate interior angles of parallel lines are congruent. But there's another way if I wanted to be different. There's one more theorem that allows us to say that those angles are congruent to each other. Does anybody know what that would be? We just learned it in this lesson. Yes. So I could repeat all this if I wanted to, because we just showed parallel lines cut by transversal, alternate interior angles are congruent. But we know, if we already know that these two are congruent to each other, the third angle theorem allows us to make the statement that the last pair of corresponding angles are congruent by third angle theorem. Third angle theorem. Therefore, have you ever seen that? Do you have it on the beat? Do you see that?
Oh yeah.
Therefore, triangle. This is, we have to show, we need the congruent statement. X, Y, W is congruent to. Now the order that I put this in does not matter of the first triangle. The order of congruence of the first triangle does not matter, but the order of the second triangle matters. Because whatever is congruent to X has got to be first. Whatever is congruent to Y has to be second. Whatever is congruent to W has to be third. So that would be Z, W, Y. Because now we know that all parts are congruent, right? All corresponding parts are congruent. Any questions? We have another lesson. I will give you extra time, but I would try to do as much of both homeworks as you can. All right, while you're writing that down, you're going to feel like a lot's coming at you today. I'll give you one of these in case you don't have to do this, just so that you know what we're talking about. I messed up the corner of this when I was cutting it. What? It's okay. Well, yeah, it's okay. Because the people who are not here, they'll know what we're doing. So read that real quick, and then I'll talk to you about it. All right, so take a quick look. Now, this is okay, but it's pretty simple. You don't want it to be too difficult, because some of these can be pretty hard to do. But you also, I mean, this one can be done, like, in no time. You know? And that, it's okay, but if, you know, you want a good grade. So, there's a swan, there's a shirt. Can anybody guess who made that? Alden. Heart, flower, rocket, envelope, the note inside. And then this is above and beyond, for sure, because that's a bunch put together. That's pretty neat. This is neat. They're all neat. This, a lot of these have been handled a lot, so they don't look as good as they used to, but this was really neat. It was a squid, but it's kind of losing its shape. This would be the most common. This looks like maybe a dragon. I'm not sure. This one looks like it's a little more difficult than some of the other ones. So there's different levels of difficulty with some of the same things. The frog, you can make it hop. It's supposed to be able to make it hop. I don't know if I can do it. But okay, so here's the thing. How do you know if it's difficult or not? What level? Because I had somebody one year to pick Yoda, and I think it turned out, but I don't have it anymore. They took it back. Of course, if you put in that much work, you want it back for sure. But you know, if it's too difficult, we're talking about a lot of time it could take to do something like that. So just you can tell by how many folds, like how tiny, like that squid was probably, it may not look difficult, but it probably was, I would guess. So, and some that look simple are maybe more difficult than you think. But what you'll do is, so there'll be two options. You can either follow step-by-step directions on, which some people prefer to do, or you can watch a video. I prefer the video because sometimes the step-by-step, you'll follow all of these steps and you'll be doing everything right, and then they do something you're like, I don't know what that is. They'll say, do a certain kind of, they have names for certain folds, and they don't show it really well on the steps. I'm like, I have no idea. So I've done all this work and I cannot complete it. So just make sure that you look through the steps and read through them before you try to do it. I'm way better at following videos, but because I can pretty much copy anything anybody else is doing as long as I can see it, what they're doing. Oh, here was another one. I don't think I showed it. Oh, yeah. Somebody, I don't know if they printed this paper out. But now, these were just extra, because these were pretty, I think, pretty easy to do. They may not look like it, but I think they were pretty easy. Maybe not. I'm not sure. But I had a lot of people that liked this so much that they did like 2 or 3 of them. So, anyway. And then there's something beyond just regular origami where you're making shapes. And this doesn't seem like that big of a deal, but it's pretty sturdy. Pass that around. Now this I'm not expecting anybody to do. I just wanted to show them to you. And if you already know how to do something, try to do something different. Like if you know how to do a throwing star, do something different. Some of you all know that. And then, have you ever seen this little star thing?
No.
Yes.
Yeah.
William knows how to make them.
But try to do something you haven't done before. That way you challenge yourself. I did.
You made that?
Mm-hmm. I was at a workshop, and I will tell you something. That looks like it wouldn't take long. It took a long time because there are, how many? A bunch of individual origamis. I'll show you. Let me see it. So you have to learn how to fold one, and then you fold a bunch the same way. And everybody had different. So this was like a bunch of. I probably won't be able to get it back. It doesn't look that bad, but when you take a piece of paper apart and see all the folds, that takes a long time because they have to be perfect. Like you have to be careful and fold them right, and I'll probably never get that back. But then once you get it back, you have to fit it in certain ways and make it work. So if I have time, I will try to get this back together and
No one else got
put it back to pass it back around. Let's see, where did that one go? I'm glad it's mine.
I'm sorry, Brian.
I don't know. Okay, I'll get back to it in a minute. But anyway, just like I said, make sure. Oh, and before you leave today, I want you to pick out origami paper that I bought for you to use.
Thank you.
So
Thank you.
it's
You want
easy.
to get your
If you decide, hey, I want to use construction paper because that's all I have, not easy. Because the thinner the paper, the better. The thicker the paper, the harder to make the folds perfect. So Also, before I forget this part, you have to start with a square.
What?
So let's say you don't use my paper that's already a square. How do you make a piece of paper into a square?
You fold it like this.
Like that?
Yeah. And then you
Okay.
cut that.
Now tell me, why does that make a square? If I were to cut that off, why does that make a square?
This makes two perfect.
Because it makes, yeah, it makes two triangles.
I could make two triangles out of,
Because they're congruent.
this would be two perfect triangles. Two perfectly congruent triangles. If I did corner to corner, that's two perfect triangles congruent. You know that?
I have no
If I cut them out, they're exactly, well, if I fold it perfectly. But they're the same, it's just turned. So I need more information. Tell me why that's a square. What makes a square? If I cut this diagonal, I still have two right triangles.
Oh.
You try? What's the difference between a rectangle and a square? Okay, well, let me back up for a second, because I made that sound like squares and rectangles are two completely different things. Is a square a rectangle?
Yes.
Always, sometimes, or never?
Always.
Is a rectangle a square?
Sometimes.
Sometimes, always, or never? Sometimes. Okay, good. So when a rectangle is a square, that means it has four congruent sides. So when you fold this over, that is making this side, when you cut that off, the same length. So these two consecutive sides are the same length. And then these two sides will also be the same length. Okay, you get the picture. You get the point. All right. Any questions about the origami? Would you like to know
When is it due?
when is it due? Not this Friday, but next. So you have 2 weeks. This is something you can do in very little time, or you can spend as little or as much time. I will tell you though, if you look at something and it takes you like 3 minutes, then you probably need to do it differently. And don't get someone else to do it for you.
She will find
Find
it.
I will find you.
To make sure that we didn't get someone else to do it for us, are you gonna like make another one?
No, you get a zero.
Hey, that's a good idea.
Oh,
No, I could dust it for fingerprints.
That's
I can't do
I don't
that.
consent to that. My fingers will not be done. You would find them and burn them down.
That's burned my fingerprint.
Okay. Anyway, people can't keep a secret. That's why you shouldn't let anybody else do it, because
Yeah.
just when you think somebody will keep a secret, they don't. They don't. They don't. They never do. All right, so that's project number 1. Project number 2 will be before the end of this semester, and we're going to build bridges. It's fun.
Last year,
Ruby Bridges.
All right, write this down, and we'll go through this section. Okay, this section, you may still be writing, but I'm gonna go ahead and get started. Friday's section, or the section we just finished, you had to show that in any two polygons, if you want to prove that they're congruent to each other, all corresponding sides and all corresponding angles have to be congruent. But if we just talk about triangles, just triangles, there's a shortcut to proving congruence. And this is one of them. There are 4, and this is one. Side, angle, side, congruence. If I give you 2 sticks or straws or whatever it is I would want to cut, of 2 of one length and 2 of another length, and you separate them, and you take, and I say, okay, put those 2 sticks 100 degrees apart, and then put the other 2 100 degrees apart. If you connect the ends, you have 2 congruent triangles, and that's what this is showing. Side angles, if you can just prove that these 2 sides are congruent, these 2 sides are congruent, and the angle that's in between those 2 sides, formed by those 2 sides, are congruent, which is called the included angle. This is very important. For some reason we have a hard time with this. The included angle would be in the angle formed by the sides that are congruent to the sides of the other triangle. That's the included angle. That's why side, angle, side, not angle, side, side, or side, side, angle. The angle has to be in between the 2 sides. Just like it is here. And that is side, angle, side, congruence. Or SAS congruence. There will be times that the book will answer something SAS. I want this word next to it, congruence, because at some point we look at side, angle, side similarity, and there's a difference, so you need to differentiate between the 2 by putting congruence next to it. Yes?
Where would the included angle be in that
Right here, between the 2 angles. All right. The next thing I wanted to do, but we don't have time today, is to construct 2 triangles using this theorem to prove, but we will at some point. We'll probably put them all together like we've done in the past. So we'll skip over the construction today, and then we're going to look at number 10 in your book. You don't have to write that down, you just need to answer it the way I answer it because it's in your book. Decide whether enough information is given to prove that the triangles are congruent using side, angle, side congruence theorem. And explain. So, look at the 2 figures. Are they congruent?
Yes.
How do you know?
Because they're 2 sides of an angle.
Okay. Would you say that M and Q would be the included angles?
Yes.
Because it's between, right? If it was this angle over here and this angle over here, it would not be. We couldn't determine that they're congruent. But this is not a congruent symbol. How do you know that M and Q are congruent to each other? They're both right angles, and all right angles are
90
congruent. They're all 90 degrees. They're all congruent. Right. Seems like we shouldn't have to say that, but, you know, it's not always straightforward. Okay, so the answer is yes. The reason, explain. 2 pairs of corresponding angles congruent. Let's shorten this up. That didn't work. Two pairs of corresponding angles and the included I messed that up. Not angles, is it? You don't want to tell me, do you? Sides. And the included angles. Two pairs of corresponding sides and the included angles are congruent. That's how we know. One more problem. Oh no. Let's just look at this one real quick because we're running out of time. I forgot we had this one.
False.
The answer is no. Why?
There's
Not enough information. You do know that two pairs of corresponding sides are congruent, don't you? Because they share this side, right? But we don't know anything about the angles. Actually, we do. We know that this angle is congruent to this angle. But is that side angle side congruent? No. That is not side because it's not the included angle. So the answer would be no. And it's because we don't know if the included angles are congruent. So the answer is no. We don't know if the included angles are congruent. We have to save the rest of the time for this next problem. You need to copy all of that down, even if it is in your book.
Wait, so 14 is no, we don't know those, right?
We don't know if the included angles are congruent.